Welcome to Pre-Calculus. Today we will investigate solving rational inequalities, continuing to find algebraic and graphical strategies to determine solution intervals. We'll take a look at two examples. So our first example involves a set of two fraction expressions. So on the left I've got 6 over x plus 4, and I'm interested in when that fraction is less than or equal to 5 over x plus 3 on the right. So our strategy that we had developed in our first investigation of rational inequalities was to find zeros, vertical asymptotes, horizontal asymptotes, and then interpret the graph to solve the inequality. And we want to do the same here, but we have an additional initial step. And that step's necessary because I need this right-hand side to be 0. I don't want anything on that side except for 0. So before I can be investigating for x-intercepts, vertical asymptotes, horizontal asymptotes, I need to rearrange this rational inequality. So what I'll do first is I'm going to subtract the 5 over x plus 3 and cancel it on the right side. And I'm going to let it move over to the left-hand side. So at that point, I'm going to record that difference, but I don't really want to leave it as two fractions. So pretty quickly, I want to combine that so that I have just one single fraction over here on the left side. So remember, to combine fractions, I need to get those denominators the same. So as I look at my denominators, I see that I've got x plus 4 and x plus 3. So my least common denominator is going to be both of those. So what I need to multiply this left fraction by is x plus 3 below and then above. And I need to multiply the right fraction. I have x plus 3 there. I need to multiply it by x plus 4 below and above. And what that'll ensure is that I've got the same denominator, and then I can combine my two fractions as one fraction. So we'll write that now. Now that I've got this as x plus 4 times x plus 3, I'm going to put my numerators all together. So this is 6 times x plus 3 minus 5 times x plus 4. And then to make this easier to deal with when I go to treat it as a function, I want to combine like terms in my numerator. And I also need to distribute before I do that. So I'm going to distribute the two constant numbers there. So that's going to be 6x plus 6 times 3 is 18 minus 5x minus 20, still all over x plus 4 times x plus 3. And then I'm going to combine like terms. So 6x minus 5x is going to be x, and 18 minus 20 is going to be minus 2. And that is the function that I really want to find now: zeros, vertical asymptotes, horizontal asymptotes. So what I'll be working with is this single rational expression on the left, less than or equal to 0. I want that right side to be 0. So we got it there. So let's engage in that procedure now to graph the function. So I'm going to look for x-intercepts. I want to find any x-intercepts. And I'm going to do so by setting the numerator equal to 0 and solving. Because if I can get that numerator equal to 0, then it doesn't matter what the denominator is. 0 divided by anything except for 0 is 0. So my numerator is just x minus 2. So I'll set that equal to 0. Solve real simply by adding 2 to the left, cancel, add 2 to the right, keep the balance. And I get a 0 here at x equals 2. So what I'll do is I'm going to start to graph this over on the side with these essential points. So there I'm going to find 1, 2, and I've got an x-intercept. So the graph is crossing through at the x-axis there at 2. The second features that I want to find on the graph are the vertical asymptotes. So I want to find the vertical asymptotes. And like we did for our x-intercepts, I'm going to set now the denominator equal to 0 and solve to find any vertical asymptotes. Remember, vertical asymptotes are places on the graph that are undefined. So if I divide by 0, that's definitely an undefined operation. So my denominator is going to be x plus 4 times x plus 3. So that's already factored. So I will set each of those small factors themselves equal to 0. And then I want to solve those small binomials. Pretty easy to do. On the left one, I just need to subtract 4. On the right, I need to just subtract 3. We get two very close vertical asymptotes. So one's at -4, the other's at -3. So I'm going to graph both of those, really just sketch them in on my graph here. So that's on the left side of the y-axis, 1, 2, 3, and 4. So I'm going to sketch those in. Vertical asymptote through -3 and through -4. So it really just partitions a thin slice of the plane there between -3 and -4. Last thing to find before I go graph this on Desmos and create my graph here is I want to find the horizontal asymptote. And remember, horizontal asymptote's a comparison of the high powers on the x terms in numerator compared to denominator. So if I look at the circled one where I've got the fraction on the left and 0 on the right, I see that my high power of x in the numerator is 1. In the denominator, I have 2 occurrences of x. Now they're factored. If I were to multiply those back and distribute, that would be squared. So the high power, if I were to look at it like a polynomial, would be in the denominator. So if the high power is below, that's really good news, because that means that I've got an x-axis horizontal asymptote. The high power is below the x-axis is my horizontal asymptote. So I'm going to sketch that in. So all the frameworks in place, what we need to do is decide where the graph is placed within that framework. So to do so, I want to just graph my circled inequality there as a function on Desmos. So I'm going to type it in, f of x equals x minus 2 over factored x plus 4 times x plus 3. And there's our graph. So I just want to notice some stuff about it. On the left-hand side, in fact, let me place my vertical asymptotes. So -4 and -3, and then the x-axis. So that's y equals 0. That's my horizontal asymptote. So I see that on the left of my vertical asymptote at -4, the graph's entirely below the x-axis. I don't see anything in between -4 and -3, but I think if I were to increase my y minimum, let's increase it to -30. We'll keep going, -50. So if you investigate and you aren't finding something, go to the other side. So I'll leave that at -10. Let's see if there's any part of the graph on the upper side. So let's go to +30. And sure enough, I see the graph has a small kind of even type function there in between -4 and -3. So I did want to see if that existed there, and it does. So I'll remember to put that above the x-axis. On the right of the vertical asymptote at -3, that graph's below the x-axis. Now we did have a solution at 2. So I see that right here at 2, it's a value of 0. On the left, it's, let me make sure to grab onto my actual function. So the function comes up to 2. It's negative until 2, crosses over the x-axis, and has positive values. So this is a unique type rational function that passes through the horizontal asymptote and then approaches it from the opposite side that it crossed it. So on the left of 2, it's below the x-axis. On the right of 2, it's above the x-axis. So I've got that kind of placement in mind, and I'm going to take it back to my graph just to sketch it. So just to recall, on the left side of vertical asymptote at -4, the graph's below. In between -4 and -3, it's above the x-axis. And on the right side of -3, it's below up until 2, where it crosses through and then approaches the x-axis from above as it heads out to infinity. So that's enough for me to solve my inequality now. So I just need to go back and look and say, I'm looking for where this function is less than or equal to 0. So the places on the graph where it is below the x-axis include this left-hand piece. Does not include that piece between -4 and -3, because that's above the x-axis. That's greater than 0. But it does include this right piece all the way up to 2, but not past 2, because those values become positive. So I'm going to record my solution set. So it would be from -infinity up to -4, including parentheses on both those, because neither of those is an actual point where it equals 0. I'm going to put the union symbol and pick up at -3. So on the right side of the vertical asymptote at -3, all the way to 2. And since I do have the equals bar, so I'm saying where is it less than or equal to 0, I would include 2, because the graph actually passes through the x-axis at 2. And that would be indicated by that bracket. And that completes the solution set for this rational inequality. Let's take a look at a second example. So here in our second example, I'll only have one rational expression there on the left, x squared minus 3x minus 18 over x squared plus 6x plus 8. Zeros on the right. So the setup in terms of structure is acceptable. I'm ready to start. So what I'll do is I want to begin by looking for zeros, but what I really need to do first is factor. I need to factor the numerator and denominator. So my numerator is x squared minus 3x minus 18. I'm looking for two numbers that multiply to -18 while they add up to -3. And that's going to be given by -6 and +3. -6 times +3 is -18. -6 plus 3 is -3. So it checks out, it factors well. Let's factor the denominator similarly. So x squared plus 6x plus 8, I'm looking for two numbers that multiply to 8, while at the same time they add to 6. Multiply to 8, add to 6. So that's got to be 4 and 2. 4 times 2 multiplies to 8. 4 plus 2 adds to 6. Now, I'm ready to look for x-intercepts. So as I'm writing, see if you can recall, where do I need to go, my numerator or my denominator, to find the x-intercepts? Very good. I need to go to my numerator, set it equal to 0, and solve. So I'm going to set that numerator in its factored form equal to 0, x minus 6 times x plus 3 equals 0. And since it's got two factors, I set them independently equal to 0. And then solve those small binomial equations. Easy to do. Add 6 on this left one. Subtract 3 on this right one. So I get two x-intercepts. One is at 6, the other is at -3. So I'm going to begin sketching our graph. Remember, our approach here is both algebraic and graphical. So the algebra we've done with this solution on the right, now the graphical approach will help us interpret the inequalities. So they're at -3. I'm going to place an x-intercept. I also want to place an x-intercept at +6. 1, 2, 3, 4, 5, and 6. So that puts in my zeros, my x-intercepts. Once I find those, I then want to turn my attention to locating any vertical asymptotes. I want to find vertical asymptotes. And as I write this, try to remember, should I go to the numerator or the denominator for that? Good. So I went to the numerator for the x-intercepts. For the vertical asymptotes, my attention is drawn to the denominator. I want to set it equal to 0 and solve. Because remember, if my denominator is 0, that's an undefined place on my graph. And that really is what a vertical asymptote is. It's an undefined place on the graph. So I'm taking my denominator, x plus 4 times x plus 2, set it equal to 0. That has a really identical solution strategy to our first work with the zeros. So I set those binomials independently equal to 0. Easy to solve. Subtract 4 on the left. Subtract 2 on the right binomial. And I see I got two vertical asymptotes, one at -4, one at -2. So those I'm going to graph. So at -2, I've already got that placed. And what I can see is that my vertical asymptotes surround the part of the rational function that includes my x-intercept. So there's some part of that graph that crosses through the x-axis between those two vertical asymptotes. So we're almost done with our framework. The only thing I need to find now is what is the horizontal asymptote. So remember, the horizontal asymptote is a comparison between the high powers in the numerator and the denominator. So I'm going to go back to the original for this. My high power in the numerator is 2. High power in denominator is 2. So what I see is that my high powers are equal above and below. High powers equal above and below. So remember, our interpretation of that is that my horizontal asymptote has moved off the x-axis, and I find its location by taking the coefficients on the high powers. So that's the equation y equals 1 over 1 or 1. So essentially, the horizontal asymptote is just lifted up off the x-axis, and it passes through the y-axis at +1. So there's our framework. Again, we find that framework so that then I can place the graph and then interpret the graph to solve the inequality. So what I want to do is I want to go to Desmos again and graph that, again, just to place the graph. So the emphasis here is not on getting a table of values and making a super kind of precise graph. I really just want to place it. Where does it exist? So let's type our function in. So we've been working with, let's go with our factored form. So x minus 6 times x plus 3 in numerator over x plus 4 times x plus 2 in the denominator. And I'll hit the home key just so we can kind of see that function. And let's place our asymptotes in place. So we had the two vertical ones. We had x equals -4 and x equals -2. So you can see that fits well in my graph. We also had a horizontal asymptote at y equals 1. So I think probably this is a good one to zoom out a little bit so I can kind of see where the graph is. So on the left-hand side, the graph is above the horizontal asymptote. In that little slice between my two vertical asymptotes, I've got what looks to be kind of like a cubic function, one arm down, one arm up. And then on the right side of the vertical asymptote, that function is below the horizontal asymptote. Once I see that, I'm good to go. I really just need the placement. So I'm headed back to the notes. And I'm going to sketch this graph. So from what I saw, this left side's above the horizontal asymptote. In between, I have part of the function below, passes through, and continues forever. And then on the right, this is below the x-axis all the way until 6, and it passes approaching the horizontal asymptote as x heads to infinity. So at that point, all I need to do is locate these parts of the graph that are less than 0. So on the left side, there's nothing because that whole left piece is above even +1. So that is not included in my solution set. But in between my vertical asymptotes, I've got part of this upright graph really from -4 up to -3. It ends at -3 because then it passes through the x-axis and the y values become positive. I do pick up again on the right side of -2 all the way up to the x-intercept at 6. So those two pieces are going to form my solution set. So I'm going to start with a parentheses because that's a vertical asymptote. The graph doesn't touch it. And that's at -4. And that continues up to -3, my x-intercept there. Now this is not less than or equal to, it's just less than. So I'm going to put a parentheses, union, and then I'm going to pick up with the right side of my vertical asymptote at -2, and that continues up to my other x-intercept at 6. And that is my solution to this rational inequality. Thanks for this, for joining this continuation of our investigation of solving rational inequalities. I'll let you solve your own rational inequalities. See you soon.